So let's try another example with finding a range of third side measures. So we're given two side lengths. We're given the side length of 7 and we're given a side length of 6. And we're asked to find a possible range of values in which could be our third side length to form a triangle with these two side lengths that are given. So what I'm going to do here is I'm going to label A as 7 and I'm going to label B as 6. And what we're looking for is we're looking for C. So we have three criteria that gives us that tells us how we should have triangles. So the sum of A and B has to be greater than C. The second criteria that needs to be met is that the sum of side lengths B and C have to be greater than A. And then the third criteria that needs to be met is that the sum of A and C must be greater than B. So what we're going to do is we're going to replace any A that we see in these inequalities with 7. We're going to replace B with with 6 in any of these inequalities that we have here. So in the first one, A is 7. So we're going to say 7 plus B, which is 6, needs to be greater than C. Now, when I take 7 and 6 and combine that, that's going to give me 13 greater than C. So that's going to be the first criteria that needs to be met. Now, in the second one, we have B, which is 6, plus C, that's what we're looking for. That's our current unknown. The sum of those two need to be greater than A, which is going to be 7. Now, what I need to do in this inequality is I need to solve it for C. So I need to isolate that C, get it by itself on the left-hand side of my inequality. So that means this positive 6 has got to go. I got to get rid of it. So I'd perform an inverse operation of subtracting 6 on the left-hand side. And what I do on the left-hand side of the inequality, I must do on the right-hand side. So I'm going to subtract 6 over here as well. Now, the 6's on the left are going to cancel each other out and give us 0. The only thing we're going to have remaining there is that C. And that's going to have to be greater than 7 minus 6, which is 1. So the second criteria says that C values have to be greater than 1. Now, in my third criteria here, we have A, the sum of A and C has to be greater than B. So A is 7 plus C, what we're looking for, should be greater than B, which in this case is going to be 6. Once again, what I'm trying to do is I'm trying to solve this inequality for C. So I need to isolate that C. I need to get it by itself on the left-hand side. I do that by subtracting 7 from the left-hand side and then subtracting 7 from the right-hand side. Now, these 7s are going to cancel each other out. It's going to leave me with C, and it's going to leave me with, I can do a better C there. It's going to leave me with C being greater than negative 1. Okay, so according to these three criteria, this is what needs to be met for C. C values have to be less than 13, which is okay. We can have side lengths of 12 or 10 or 5 or 2, okay, or things in between, like say 2.5. The second criteria says that my C values have to be greater than 1. So that can easily be met. We can say 1.5. We could say 2 2/3. We could say 7 or 8. So this would work. And then in my third criteria, we see that they want C values to be greater than negative 1. Well, greater than negative 1, we could have a side length of, say, negative 1/2, but that's not going to be possible because, once again, measurements or measures of length cannot be negative. So this is not going to be possible. So we're going to have to throw that one out. So in this one, the possible side lengths of the third side, that once we have, say, 7 and 6 as our other side lengths given, our C values have to be greater than 1, but they also have to be less than 13. So anything that's in between those numbers of 1 and 13, not including those two, would be a possible side length if you have already side lengths of 7 and 6 in order to form a triangle.